Okay. This talk is about VPN, in particular about npppd, which is a new VPN daemon in OpenBSD 5.3, which will be released next month. I work on OpenBSD mostly on ports, but I have my own source route, so I not only work on ports, but I work on also on some usual and daemons I used to work. A couple of years ago, a customer called me. He had initially a central office with a Windows server. He told me, well, I opened a new office 200 kilometers far, but I have a problem with the network because if I go in Windows neighborhood, I cannot see the central office. I said, well, it doesn't work this way, it's not connected. So you have to connect the offices, you have to create a kind of connection. So we proposed a solution based on VPN, based on OpenBSD as a VPN concentrated on a firewall, and both offices will connect to central Windows server in a web form. The main problem initially was we have to decide which VPN software we would use. We wanted to use OpenBSD as a firewall because we had deployed many others to other customers. We could use IPD, but IPD it has some problems with user password authentication a couple of years ago, and it requires Windows 7 for the client part. And budget customer, we have Windows XP, Windows Vista 7, Mac OS, and all kind of other stuff, so it was impossible to use. Then was OpenVPN, but I don't like it that much, because to do some accounting you have to create some scripts. Then they were thinking also about maybe in the future to use iPad to connect it with their main software. So I'd like to have a solution which will be on quite every platform. Then we do was PopTop, which is important on BSD, but it's quite slow. So we're trying to search for another solution. There were an initial import of npppd, which is a PPTP and L2TP daemon, quite a month before this project started. This import was only in source form, not yet linked to the build. It had some little problems, like there was no documentation, and all comments in source code were in Japanese, so it was a little tricky to debug some problems. Anyway, npppd main features is a PPPP tunneling daemon, which supports PPTP protocol, HTTP protocol, and PPP over Ethernet. At the moment, I currently use PPTP and HTTP, and never use PPP over Ethernet. I can authenticate users using a local file or a remote radius server. Then the main developer created also a kernel interface, which is Pipets, which is used to accelerate packet forwarding between user land and kernel space, but it's an optional. It's enabled via syscontrol, and it's an optional thing. Then you can use combined with tool interface or PPPX interface. The main difference is that with two interfaces, you have one interface for all your users. With PPPX, you have the daemon auto creates an interface for every user that's connected. So if you have 100 users connected, in fconfig you will have 100 PPPX devices. It was initially developed by EEG, which is Internet Initiative Japan, and the first appeared in OpenBSD 5.3, which will be released next month. Anyway, it was for about a couple of years in source code, so I started working on it and using production, even if it was not yet linked to build. The main configuration file is under npppd.conf. The configuration format has changed a lot during development. Initially it was an in-style config file. Now it was something more like GPD or PF syntax, or something more BSD style. This is simple configuration. We have an authentication using the local user file, definition of the protocol and the bind of the interface you will listen, and then the HTTP parameters like pool address, DNS server, and Win server, and all the stuff you want. And then the binder in the interface you will use, or in this case you will use PPX interface. It will automatically create a PPX0 interface with this address, and then every user will it will create PPX1, PPX2, PPX3, etc. The user's file, the local main developer has changed to use getcap as a user file format. So you have the user and then the attributes, which is the password, and in this case there's a frame IP address. There's a bug in previous. Unfortunately, there's a bug in libc getcap, at least in OpenBSD. I don't know with other BSD I haven't time tested, that you cannot have a value with a colon inside. So a password with a colon inside won't work, because it splits by colon and it won't work. I read that in getcap there are some tricks with by writing / something to escape, but I haven't tried it yet. And a more advanced configuration is requiring a radio server, and you can define a radio server for authentication purposes and a different radio server for accounting purposes to register all information about past connections. Then you can use, if you want, HTTP, which is more secure protocol, but it relies on IPsec, so it has all the IPsec crypto over the infrastructure, so it's a bit slow. With this project, at the end, I've choose PPTP because I tried HTTP with 3G connection, because the ESL laptop they connect to the main software from everywhere, but HTTP with 3G connection, at least in Italy, is not yet very fast. HTTP setup, you have to set up HTTP with the previous definition, so you get point to the database of users. Then you have to configure IPsec.conf, because it relies on the standard IPsec stuff. And obviously you have to change PF to filter the right port. IPsec, this is a IPsec configuration. You have to define your public IP address, which if you are behind NAT is not the public interface, public IP address of your interface, but is public IP address of your router. So it's a bit tricky, mainly because of some Windows bugs. I will talk later. If you have, for example, your firewall which has a public interface, which has 10.0.0.1, and your router have 199.9.8 here, you have to change your router IP address, because Windows has some bugs and it tries to connect to the internal IP address, so it doesn't work. Another strange thing is that when you define the crypto setup, you have made to define a lot of channels, because Windows XP has some defaults, Windows Vista has some other, macOS has some other, and to change that in the client part is not so easy, because you have to change in the registry default values of crypto defaults. Okay, then you have to configure PF to pass the stuff. Then you could use npppd as a counterpart in user language, which is nppp control, to monitor the status of your VPN. You can see the username, the realm, the concentrate interface, which will be tune or PBX 1, 2, etc. Your assigned IP address, the protocol, the public IP address, and some information about packets which passes through the VPN. All this information, if you use a radius accounting, are saved on the radius database. So you can see in the past at a specific time who was working on VPN, how many bytes has downloaded, and if you can kind of, for example, if you use VPN over Radiant, you can kind of billing related to downloaded packets or something like this. If you use PBX, you have your interface, and on the description you get on the interface you get your user, which is connected to this interface. So by simply typing in ifconfig, you can see which users are connected on the VPN. Then there is a PBX group, which groups all PBX interfaces. So in PF, you can filter for interface groups PBX. So you can, for example, do traffic shaping or whatever on VPN. Maybe in the future there will be a more fine-grained integration with PF to be able to filter for a group of users or something like this. I haven't yet decided how. If you use HTTP, well, IPsec control is your very bad friend. So you can see all the flows and the association. Then, well, if you get radius, you get probably a backend with the database. Database is radius database, at least on free radius, is 4 or 5 tables, so it's quite simple to write a user interface, so to grab some GPL or BSD like radius admin, dial-up admin interface, and to change just little to be able to create users, notify users, to see how many users are connected to the VPN, and then to be able to read all accounting data, so to be able to view who is connected to the VPN, for how many times it's connected, and even in the past, all the information about accounting data. Okay, then to come the the tricky part. Because if you have to play with PPTP, HTTP, you have to play with Microsoft too. So, the first problem was that in the VPN, there was in IPCP configuration there was applied the DNS used. The main problem was that the computer, which is connected with the Windows 2003 server, if the VPN gives a DNS server, it uses by default this DNS server. So it can resolve no more the internal server. And if I configure the internal server, the ones that connect to the other office cannot use the internal server. So it was easily fixed by not setting any DNS, and Microsoft uses the one configured in the adherent interface. The other problem was, well, I was lucky for a lot of time with that, because when the computer started, it authenticates through Active Directory. Windows Server gives a Kerberos ticket. The other interface is as the standard NTU, so it has 1500 NTU. And Kerberos ticket fits in 1500 NTU. Then the computer connected to the VPN. The VPN as a standard has 1360 NTU. The client, for I don't know which reason, changed the NTU of the adherent interface. So after 15 minutes, the Windows Server tried to renew the Kerberos ticket. It doesn't fit no more on the NTU. It thinks that there is a middle attack, and it disables your account in the Active Directory. So you have to disconnect to the VPN. The adherent interface changes its NTU to the default one to 1500. The Kerberos ticket gets renewed, and then you can reconnect to the VPN for other 15 minutes, and then all things start. Well, in the very end, all the workaround was to set the VPN NTU interface to 1500, which was the faster solution. The other solution could be to change all computers NTU, which is crazy, or to call Microsoft for support to fix something. Okay. Yeah, this is another joke. On my office, I have a VPN which is behind a router which has NAT. I try to set up my HTTP VPN, but it fails. I try to do that issue. At the very end, I found a Microsoft article which said in Microsoft XP Service Pack 1 we have NAT-T support, but it was a bit buggy. So with Windows XP Service Pack 2 we completely disabled NAT-T support. So if you want to enable NAT-T support in Windows, at least in 7, don't know, I've never tried Windows 8, you have to change this key registry, which is far easy to remember, and you have to change the D word value from 0 to 1 if your client is behind the NAT, and to 2 if your client and your server is behind NAT. Anyway, HTTP it's a bit slow, maybe because at least from the test I had, it was I was using AES Mod P 2048, so it has strong crypto, and well, I have quite old laptop. I have but you can use it for a daily use. This customer is using every day. He has every computer, every laptop is connected to the main server, and it's working quite well. Okay, the future of npppd will be, well, first fixing bugs. I have some in my to commit list. A better integration with PF. We thought about filtering by group of users, maybe by adding a group in the radius and user definition, and then adding the group interface to the PBX interface, maybe by adding a tag in PF, but we have to discuss with PF guys to think which would be the best solution. One other thing that definitely is missing is hard cache support. This means that at the moment you have to separate the LAN subnet of your LAN and the subnet of your VPN users. You cannot share. To be able to share your LAN segment from VPN and LAN, you have to enable hard cache support, which at the moment there's no code for it. There was last year a great review of all the stuff. A lot of bug fixes, and in October has been committed with finally with map pages. Some months before there were finally the comments in the code in white English, which was far better than Japan. And we will try to use and to think about other things to add, because I think it's a great piece of software. It would, at least for the user line part, I think it's not be too difficult to port it to some other BSD, because I think the IPsec stack is quite the same, so it's not bad, too complicated.